The de Havilland Comet was the world's first commercial jet airliner. It was manufactured here in the UK, in Hertfordshire. It marked the dawn of commercial air travel, a new age of luxury. But the Comet 1 was short lived. It suffered three fatal crashes in the 12 months between May 1953 and April 1954, and shook public faith in the prospect of commercial air travel. Crucially, the crash of Boeing Flight 781 caught the attention of many. An explosive decompression at altitude, resulting in several equipment failures, seemingly for no reason. A lot has happened since Comet 1 crashed nearly 70 years ago, and we now understand exactly what brought it down. What was to blame was metal fatigue, a poorly understood concept at the time. When metal surfaces are exposed to continuous wear, they endure fatigue, which can lead to the creation of microscale cracks. These cracks can break apart the material and compromise its integrity. When this happens, a best case scenario is that your car needs a service. But in the worst possible case, as Boeing Flight 781 proved, the outcome can be deadly. According to the Air Transport Association, global aircraft maintenance topped £50 billion in 2018. It's a huge industry and a costly one. Any changes that can be made to better streamline the maintenance process mean better industry practice and safer travel for passengers. Regular inspection is effective at keeping the problem of metal fatigue at bay, but for proper long-term treatment, a process like laser shock peening is required. In laser shock peening, a high-energy laser vaporizes the surface of the material, and the plasma generated expands rapidly. If confined properly, this generates an explosive shockwave. This shockwave impacts the material, denting the surface slightly and forcing surface-level cracks and stresses to point inward. This improves the metal's fatigue life substantially. This method has a similar effect to traditional wear resistance methods, but is capable of generating compressive stress much further below the material's surface. I support a team that is researching more efficient and more effective ways of performing this technique in the hopes that we can further strengthen materials and better extend their lifetime. If successful, our research will have an important impact on the automotive industry, the nuclear industry, and most importantly, aerospace. Although much was lost when the comet went down, it also offered us an opportunity. And with it, air travel is now safer than ever before.